with this, of course, we're going to start covering the material, and at the end, I'm also going to open some questions for other logistics or the things that we covered. Last week, just to remind you, we started covering how to think of data, right? If you are running an experiment in a biomedical engineering lab, you have an apparatus, you have a device, and then in a lot of times you would have cameras that are, in a way, recording the outcomes of this experiment. And data science comes in that you have a lot of data in these experiments that you are producing, and you want to be able to generate insights about it. Right? For example, what is the impact of a certain solution on certain types of cells and so on. Last week, we started looking at structured data. We can take that data, and if we have it in a structured format, we can actually do some analysis and get some insights. We're going to continue in this type of thinking. So this is the second week, final week of, in a way, a similar approach, which is how can I ask questions about my data? How can I visualize my data? Unlike last week where we looked into databases and we looked at SQL, today we're going to look at a method that is actually more widespread and more used by data scientists, which is using data wrangling libraries, which is a Python library called Pandas. But just for me to get a sense, at least here in the live audience in front of me, how many of you have worked with Pandas before or know about Pandas? So what we're going to be doing today is that, especially for those of you who are outside of CS, we're going to provide a very quick intro to programming. We're not going to really go deep into it, but I'm going to give you enough information to help you start actually doing something with data science with Python and the Pandas library. And of course, in terms of the context, for us to see where we are in terms of the pipeline. Of course, last week we showed this pipeline in that we start from the device, we start from the experiment, we generate the live images, we then have AI detection tools and object detection models, and then we get to structured data, and then we get models and insight. Last week, we were mostly here about structured data. Today, we are going to focus on the next step, that after I have my structured data, how can I visualize it, how can I analyze it, and write programs about manipulating that data. And this is going to be the first introduction about, a quick introduction about Python. Of course, for the CS in the audience, you can focus on your bagels and skip this part. But for everyone who is used to programming, Python would look something like this, where you would, in a way, write commands to the prompt that would enable you to execute a function or an operation in the program. There is one way that is, I think, very accessible to everyone to actually start writing code. And actually, for those of you who are interested, you can open up your laptops and actually do it right now. If you go to this website, colab.research.google.com, and you access that website, it will give you an interface like this. And then you can start a new file, and then you would add a new code block by pressing this plus sign. Okay? And if you do that, it's going to give you a block similar to the block that I'm showing here, where you can write code and then test it out. So for those of you who are interested, you can go to this website and then write something like this: print hello world within quotation marks and parentheses, and then you can run it to see that it works by pressing this play sign. It's connected, and I get the output here. Another basic concept that is important in programming is the concept of variables, which is if I wanted to store some state about some object, for example, I can have a variable name like x, and I say that I want to assign a value to x, which is in this case 10. So now once I call this Python command, for the rest of the program, x is always going to have that value. And this value, you can think of it that the program has a table of everything that you defined previously that you can edit and read in future commands. In this example here, we wrote x equals 10, so we're assigning the value 10 to the variable x. And now in the future, if we wanted to do an operation like print x, which is telling the program I want to print the value of x, then it will take that value of x that you assigned already, and then it will print it out. So in this case, it will print 10. Okay. Something similar is that you can also do math expressions in these variables. So for example, if you want to define a new expression y, you can use the previously defined expressions to also create new variables. So in this case, you can say that y equals x plus 20, and then you could print that new value of y. So, let's say for the non-CS audience here, especially if you're kind of like, in a way, like this is one of your first interactions with programming, what do you think that the output of this block would be, which is the value of y is? And you are correct, we get 30. So here what we have is that we were able to write this expression, and then we would write this value based on that expression. And of course, we can have infinitely complex expressions using multiplications, division, and other operations, powers, and so on to create new values. So for example, here we defined a value for z, and you can also use functions to do specialized operations. And this is an important concept that I want to focus on, because when we started producing pandas, you're basically using pandas by calling functions. And a function, you can think of it as a block of code or a program that is already defined by someone else, or potentially by you previously, and then you are using it. So we named this function round, which is a function that was defined in the Python library itself, in the basic library, and it takes an input, which is the number that you put in between. This is the same concept here, where round is a function, takes an input, and then it performs some operation based on that code that you have that is defined elsewhere. In this case, the round function is going to round the input number. So if it inputs 2.6, it's going to output the rounded number, which is in this case 3, and I'm going to assign it to the value or to the variable k. If I do this, I'm going to get the value 3. And if I do something, for example, maybe 4.2, and I run it again, I'm going to get the rounded to 4. So you can think of these functions as like tools or like black boxes that you can use to perform operations. And this is a powerful concept, because now someone who is an expert, let's say in a certain field, maybe let's say in visualization, can create for you a library where you can just call that function and you can visualize things. And we're going to see this later in this lecture, where we're going to use these libraries and call their functions to do very complex operations in a single line. In a way, this is why you're hearing that it's becoming easier and easier now to do CS projects and to do things like websites and applications, because there's a lot of libraries that you can build on and perform these operations that are already handed off to another library.
Just course logistic questions we can answer there.
We'll leave it at the end. So let's move on. Another concept that is important when we think about data analysis and when we start using pandas for data wrangling is the concept of lists and series. A lot of times when you deal with data, you're not dealing with a single number, you're dealing with a list of numbers, right? Think of the experiment that we had before and the data set that we've seen in the previous lecture. You have a frame for every observation that you have. So you have a list of these frames and you have a list of these observations. One example list that could be useful for you is that the cell sizes, right? Remember in the last week, we were thinking that we want to measure cell sizes, we want to do operations on cell sizes. So you can think that you can store all these cell sizes as a list in your program that you can manipulate and do operations on. So for example, imagine that this would be a list called my list that contain all the cell sizes of your experiment. And the way that you can tell Python that, oh, what I'm trying to define is a list is by using this bracket symbol. So you use bracket to tell Python this, what I'm trying to define is a list. And these commas is the separator between each item in the list. So what you'll have here is that if you print it out, this is the list that you've defined, and these are the items. And once you've defined it, now you can do operations on it. One operation is that you can access the elements in the list. And you can do it also with the bracket sign. So if you say my list bracket 2, you're going to access the second element in the list. So in this case, what would be the second element in the list? So let's say, how about like if we got also someone from the non-CS audience, what do you think is going to be the output of this operation? Okay, so here it's 4, and I set you up. And the reason for this is that there is something that is very weird that we do in CS, which is we don't start counting by 1, which is we start counting by 0. This is the thing that I wanted to emphasize here, which is, of course, we as normal people, we would start counting from 1. But what I want you to all remember is that whenever I'm trying to access a list, we're actually starting to count from zero.
Yes.
Yes, we
Yes.
have a question from Zoom.
The output will be about the index. So we will start in 0, 1, 2. So the -2 will be the answer.
So what we have here is that we start from zero. So in this case, we have 0, 1, and 2, and we would get the output as 10. Okay, so that makes sense to everyone?
There's a question from Zoom.
Yes.
Is there a limit to how many numbers data we can store in the list?
When we work with programs, usually we are limited by how much memory that the machine that you have has. So for example, if you have a machine with 8 gigabits of memory or something similar to that, usually if you go beyond this size, your program is going to start becoming very slow. Without getting into much details about why, a lot of the programs work mainly with main memory, so you have to stay within this limit. Once you have data that go beyond this size, if you have data that is in the tens of gigabytes, in the terabytes, you can't use tools that just rely on programming, and you need to start using databases. What databases do is that it allows you to utilize your disk in addition to your memory. So that's not only the 8 gigabytes of memory that you have, you can utilize, for example, the terabytes of storage that you have in your disk. But now, if we count from 0, so 0, 1, 2, and we get 10. And similarly, we can define ranges. And I want to stop at 4, then I'm going to print the element at index 2, 3, and then I'm going to stop at 4 and not print that. So now we can think of how you can use that for your experiments, where you say that, well, if I'm interested in what happened between, let's say, frames 100 and 120, then you can access these records. And without getting into more complex, in a way, kind of commands and features of Python, for example, using loops and if statements, we're not going to rely on them now, but I have an example here to motivate something. Now, with having the list, you can actually start do some complex operations and complex analysis. Even something simple like, for example, calculating an average, you can do that by going through the list, right, one by one, and then adding them up, and then dividing it by the number of those elements. So this program here is doing that thing, which is I define a sum variable, and then I go through the whole list in something called a for loop, and I sum it, and then finally I print that sum divided by the number of the items. You don't have, in fact, to really understand this completely, but what I want to motivate is that even the simplest things are going to require some type of CS knowledge. This is what is nice about the Pandas library, that it is catering not only to CS audience and people with background in CS, but it actually caters to data scientists with domain knowledge, so that you have a library that you can use, functions that you can call to do these operations for you, rather than you having to implement them. So instead, what we're going to see in Pandas, instead of you having to write the actual program to calculate the average, Pandas is going to give you a function that you can just call to give you the average right away. Okay, and this is in a way the power of this, and why Pandas is going to be important for you as a data scientist. The last thing that I wanted to cover as an overview of programming concepts is the issue that, well, we covered lists, but you can also have lists of lists. You can have a list where each element of that list is also itself a list. So here is an example definition of a list of lists, which is you have the first element, this one, 1, 2, 3, which itself is a list. So that's the first element of the high-level list. And this is the second element of the high-level list. But then if you go inside one of these two lists, then you can access these individual items. So if you do something like this, which is I want to access a list of lists, and I want to get access to the first, to the item in the first index, and then within that, I want to get to the first index within that list. What Python is going to do is that it's first going to evaluate this part. So it's going to get you this one. Of course, remember, we start from 0. So you're going to first get this list here, and then it's going to evaluate the next index that you provide, which is I want to access the one with index 1 in that second list. So the output of this is going to be the number 5, because you specify that I want to get the second item in the higher level list, and then the second item in the low level list that I picked. Now, the reason why I want to show this is that Pandas rely on this structure. A lot of times when we deal with data in data science, you deal with data that is two-dimensional. That similar to what we have seen in data tables in the previous week, you have tables of data, and you have records with different features. So you can think of this could be one frame, or the information of one frame where you have, for example, the time, the ID, the size of the cell, and all the other information about your experiment. And then you have a list of all these lists of the different observations that you have. For a long time, data scientists had to do everything from scratch using Python, in fact, to write their own programs. But now there is a huge number of very nice libraries and tools that can enable you to do complex operations without having to know deep CS knowledge. So this is what we're going to start covering now. And what we're going to cover is a library called Pandas. But before that, let's take any questions. So maybe we'll start with Zoom. Any questions?
So is there a way to make indexing a list start from 1 instead of 0? Like if they're altering the index property or something similar?
Yeah, very good. So I believe that, yes. And actually in Pandas, I believe that you can do that. You can alter the indexing of your element actually arbitrarily. So you can do that. But I think at the general level of using programming languages, that would be the default in most programming languages. So, of course, I'm asking a question in Zoom, and then you hear someone here saying the question. It's actually someone here helping us reading the questions in Zoom. So if anyone in Zoom has a question, you can write it, and we're going to stop every once in a while. And here, Yinan, our helper, is going to read it out loud. Any other questions? All right, so now continuing with Pandas, now we're going to start exploring the Pandas library. And the Pandas library, as we motivated earlier, is going to allow you to have powerful tools and functions that you can utilize to do complex operations with your data. The reason why Pandas is popular, actually, I don't know the exact number, but I believe that it had billions of downloads, billions with a B. So it's very, very popular, both kind of like for CS applications, but also in a way, the reason for its popularity is the interest in machine learning and data science and data manipulations, and that it was accessible to a wide range of users within and outside of CS. The other point that is important about Pandas, which is one of the practical problems that you would have, is that it allows you to do flexible data cleaning and exploration. A lot of times, when you start working with your data, that data is not clean. What we mean by data not being clean in data science is that you can have missing data, you can have corrupted data, you can have data that you don't trust 100%. So Pandas also give you tools and functions that allows you to clean the data. And we're going to see an example of how we can do that for missing data later in this lecture. And finally, it has strong integration with other data science tools. When you're doing a data science project, it's not only about doing the analysis and the cleaning and the exploration, but you want to do other things like visualization, exploration, and like other aspects. And Pandas have a strong integration with other data science tools. An example that I'm going to show at the end of this class today is how it's integrated to visualization tools. So you can easily visualize your data if you're using Pandas. And when we think about Pandas, it basically uses two main data concepts on how to organize your data. The first one is the concept of a series, which is basically a list. Similar to the list that we have shown a while ago, a series is the concept in Pandas that would allow you to define a list and then do complex operations on that list. For example, do the average, do standard deviation, like any type of complex operation. Another one that is actually more powerful and used even more is the concept of a data frame. And you can think of a data frame as a data table where you have rows and columns, similar to the tables that we defined in the previous lecture. But we're going now to see how a data frame now can be used and manipulated in a program rather than using the SQL interface. Using Pandas can be as easy as installing it. If you have an environment and a machine and you want to install it in your own machine, then you can do that with that command here, of course, depending on the machine that you have. And once you have it, you can import that library into your program. And we're going to see how we can do that now. For all of you here who are just starting to do programming, you don't have, in a way, to worry about all of these things. You can immediately go to Google Colab, a web interface, and call this line here, which is import Pandas as PD, which basically what it does, it tells the Google Colab environment, I want you to bring that library to me, and I'm going to be using it in my program. And we're going to see a demo of that in a little bit. Okay, so a data frame, I'm going to skip that and jump right into the notebook here that tells us, or that shows how we can use these libraries. So just to emphasize what we had before, you can go to call up the research@google.com and start your program, and then you can then start in a way following with us if you wanted to see if everything works with you fine. Of course, at the end of the lecture, I'm also going to offer Q&A if you have any questions or if you face any difficulties. Another thing, you can also use Slack. So in Slack, especially for those of you, this lecture is, I think, mostly introducing topics that might be more challenging for non-CS students. So feel free to ask in Slack, and I bet that a lot of your colleagues are going to be willing to help you out. And hopefully we'll be doing the same thing for them once we go into more biomedical engineering topics at the end of the program. So the first thing that you want to do when you want to use the Pandas library is you want to tell Python, I want to use it. I want to get that library and have it as part of my environment. So you call import Pandas as PD. So now PD is going to be the name of the Pandas library that you're going to use throughout the program. So that's, in a way, you can think of it, you define a variable that is your handler to access that library. After that, so we wrote this here, and now it's imported. After that, we would define a variable called cell experiment path, which is going to be the path to your file. And in Google Colab, you can upload your file by pressing this folder icon here, and then pressing this upload button here, icon here, and then you can pick the file that we're going to be providing in the courses website. So you can upload this file. This is the CSV file, similar to the one that we covered before. It's a little bit different. I'm going to show you how it is different, and we're going to start exploring that file. So one way that you can think of it is that you have the CSV file about your experiments data. In this case, it's the cell experiments data that we introduced last time, where you have experiment ID, timestamps, cell position, X and Y cell positions, the cell size, the cell type, and the apparatus used for that experiment. So now you have all this data, and you have a lot of entries. Like in this case, you have 5,000 entries. And actually, in real experiments, this is not even, this is considered small. So you can imagine that you have a large number of these data. So you would now define this variable so that you know where that file exists. And then after that, you would call this function in Pandas that is going to take that CSV file and transform it into a data frame for you. So remember the concept of a data frame that we introduced, which is you can think of it as a two-dimensional list or a table in a database. Pandas has a function without you having to worry about going and reading the file yourself and extracting the data and transforming it, which people had to use before. Now you just have a function that would quickly perform that operation for you. So you say read CV, and you have first you call PD. This is the Pandas library handler dots, which tells Python that they want to call something inside of that library, which is in this case read CSV. And this function is going to take the path of that file and then take it from the file and then transform it into a data frame that you can do cool things with it, as you're going to see. We have some other things. We're not going to worry about the details, but one thing that we have here is that the index column. So we're telling the Pandas library what is the column that would be the index that we're going to utilize for indexing the rows or the items in the data frame. And then after doing all of this, we are putting it in a variable called data. So now data here has all the data frame that corresponds to the CSV file. And now we can use that data as an object, a data frame that we can manipulate and do operations on. So first thing that we can do, we can just print data. If I just call data by itself without anything else, Python knows that what I want to do is that I want to see it. So it prints that data frame to me. Of course, because it's too big, it provides a type of summary. So only the first 5 and the last 5 elements. And then you can start doing some basic operations. And you can do that by calling functions. So if you call data.info, it calls the info function on that data frame that you defined earlier called data. And one of the things that you have, well, the column names, and then you have the number of null count, meaning that how many values that are not empty that you have in these with these entries, and then you have the data type. And notice that all of this is figured out for you. You didn't have to do anything. You just loaded the CSV file, and these functions just do everything for you. And so, for example, the experiment ID, here see that the data type was a float type, meaning that it's something with decimal points. If we see something like, for example, the apparatus used, the data type is an object because it's text. So it figured these things out by reading these elements. Something that is important that I want to point out here is the null count. Null is another way to say that something is empty or non-existent in programs and variables. So when I say that the null count, I'm referring to how many values do I have for that feature or that column. For example, if I look at timestamp, I see that I have 5,000, which is the number I expect. Right? I have 5,000 rows, so I have 5,000 non-null values. So I have all the timestamps for all my entries. But if I look at something else like experiment ID, I see that, well, there are some that are missing. But if I look at cell size, for example, I see that there is 100 missing values. And of course, this can happen for many reasons. It could be that there is a fault in the apparatus, in the image, in the detection. So I wasn't able to detect that cell correctly. So here we have these missing values, and this can be problematic. One way that this could be problematic is if we see this next example, if I want to get the average of the cell sizes of all the data, I can do it in Pandas by doing this command, which is data, and then I would define as an index what is the column or the feature I'm interested in. So in this case, it's cell size. And then I would call a function called mean that is going to give me the mean or average of that cell sizes of everything in my data frame. But now you just call one line, and the Pandas library is going to give you that average right away. You don't have to worry about anything. But one problem about this mean is that it gives you a mean without really factoring in that you have 100 missing values, right? So of course, it's only going to get the mean of those numbers that already exist. So what can you do to actually rectify that issue? And this is a data cleaning problem that we have to deal with in a lot of our data science projects, especially when it gets to some physical phenomena, like an experiment in a lab where things might not go as you would expect. But before we get into that, let's see some of the features of Pandas that would be useful. This is one feature that you can call something like a mean function. Another example is that you can also have selected columns where, for example, if you're only interested in the apparatus used in each experiment, you're not interested in anything else, you can define that by calling data, and then you would call the indexes that you are interested in. In this case, experiment ID and apparatus used. And if you print it out, it's going to give you a data frame that is showing only these two columns. By the way, for any of you who are seeing Pandas for the first time, don't worry, we're going to provide this notebook that you can actually use and run in the same way that I'm running here, so that you can follow along. And if you have any questions or things that you need help, and we can help in this Slack channel. So we have this here. Another thing that we can do with Pandas is that we can do conditional querying. Remember how we did that in SQL last week, where we are defining conditions on what are the things that, let's say, we're interested in. Maybe we're interested only in data entries where the cell size is greater than a certain value, right? So here we can do the same thing where if I call data, which is the data frame that I defined earlier, then inside of the bracket, instead of just picking the feature, the columns or the feature that I'm interested in, I can actually call conditions that I'm interested in. So for example, I can say that I'm interested only on data with cell size that is greater than 14. And which is a logical operator. It's like you saying that I'm interested in something in A and B. So the cell or the entry that I'm getting should satisfy both conditions. So in this case, I'm interested in the entries where the cell size is greater than 14 and the cell type is a white blood cell. So only if the entry satisfies both conditions, I want you to print those out for me. So in this case, I print these out after doing this definition, this filter data, and see that I get all the data where the cell size is greater than 14, and also the cell type is always white blood cell. Okay, so now you have this way where you can explore your data, ask questions about it as a data scientist without having to write complex queries and programs to do these operations. Okay, let's take another quick pause. Everything going fine so far? Any question, let's say from Zoom or yes?
So the question is, can you only read CSV files or can you read any other too? Like, if there's a graph or if it's a series of images?
So Pandas have, in a way, hooks to read different formats of data. So a lot of structured formats in text like CSV, JSON, for those of you who know about it, even connected to databases. We can connect to a database and get your data from there, or connect to a real-time kind of a time series hook that it can read data. So a lot of these formats are supported by Pandas. However, if it's a rich data representation like a video or an image, we have to do one more step. And this is actually what we're covering in weeks 4 and 5, which is how are we going to deal with the initial steps of that life cycle of data science experiments, which is I got the videos from the experiment, how can I transform them into raw and structured data? So we get into the issue of cleaning data, and cleaning data is also facilitated by Pandas. But before we get into how it does it, now I want you to think a little bit about this problem. Now imagine that I gave you all the experiments data for this cell measurements experiment, and you have the cell measurement of all the experiment, let's say an experiment that took, let's say 2 hours, and you have all the measurements for the 2 hours, but there is 100 of those measurements that are missing. And I told you, I want you to figure out what would be a value that you can put on those missing values instead of just leaving them empty. What do you think is an option in this case? What would you do? Yes?
Maybe like X or null.
Yeah, very good. So one option that we have is that we can have a predefined value that is going to allow me to know that this is a missing value, right? So this is one. But there is also another way of thinking about this, which is sometimes I want to put a value, I want to, in a way, try to expect what value is should go there. So what if I wanted to have a value there so that, in a way, let's say that you're maybe doing some graphs or maybe doing some analysis, and you want to have some continuity in this analysis. What do you think is one thing that we can do for these missing values? Which is, one way that we can say it is that, well, if I know the mean of all the other data points, well, I'm going to, like, in a way, interpolate and say that this is going to be the value. And this is actually what we're going to be doing here today, which is one way of cleaning data is trying to interpolate what the missing values are. Of course, in some cases that would make sense. Some cases it does not necessarily is a good option. But just to visualize what this makes sense, imagine that you have an experiment and you have these data points, right? So let's say that this is time, and these are all your time points. Let's say that what you're measuring is the cell size. So here you have the cell size. And imagine that you have all these points and this size, and then you have a missing point, and then you have these other measurements. In a way, if you interpolate, one way that you can do is that you can get the average, and maybe you get something, for example, right here, right, which is going to be the average. One other thing that you can do to interpolate is that if you have continuity, is to say that, well, I'm going to say that, well, if I know that there is some continuity in my experiment, and this is a physical phenomenon that I'm trying to measure, I can predict this as, in a way, whatever is filling this line that I'm seeing the progression of. So these are different ways of dealing with data cleaning. Sometimes I would just leave it as it is. Maybe I don't have any idea of what to fill. For example, if I'm asking what is the apparatus, maybe the apparatus is missing. Maybe I don't have a way to really, get the average of apparatuses, for example, right? But if I have something like cell size, something like an average might make sense. If I have something like a continuous function, something like this where I try to see and interpolate what is the progression of the line is, would also be a possibility. And all of these ways are facilitated with Pandas. We're going to see an example of it to do it for missing values. In this case, what we're going to do is that we are going to get the missing values by calling this function is null. And then we're going to see how many null values or null entries do we have. So in this case, we have 100 missing values for cell size. And again, all of this is done in one function, in one line where you say data is null, and just telling the Pandas library, give me all the entries where the value is null. And then you are doing a summation of all these entries by calling the sum function. And now the other thing that we can do is that we can, which is one of the first suggestion that we got, is that if I don't know these null values, maybe I just go to discard these entries, right? I don't want to how these entries impact the analysis that I'm doing. So one way that we can do is just delete those entries with null values. And instead of us having to go and write a program that goes through the whole file and CSV and do this ourselves, we can do this by a very simple function called drop NA. So whenever that we have a null value, then in the experiment ID column, we're going to just drop it and have the data be the data without these null values. And if we run this, we can see that we did this for experiment ID. And now for the new transform data where we drop the entries with no experiment ID, we see that there is no missing values because we deleted those already from the data frame. And without going into a lot of details for this one, if I can just leave it for those of you who are interested to see the details. Another thing that we can do, which was suggested by another answer about getting the average, what we can do is that we can calculate the median, and then we use the median as the value that we're filling for all the other cells. And if we do this, we can see that the cell sizes now, instead of dropping those values, what we did is that we filled those missing values by the median of all the other cell sizes. And of course, other than this, we can do some other things. For example, we can get what are the unique values of the apparatuses that are used. If you have a lot of experiments and you're wondering, well, how many of these apparatuses were used, you can do this unique function here that is going to give you all the apparatus used in your experiments. Okay, there is some other things here that I'm not going to go through the full details, but then you can also have some other things like the standard deviation, the variance, and you can also calculate these just like this by running a line, you press a button, and you get those statistics that would be useful for your analysis and exploration. Now we get into something now that is quite different. I mentioned before that one thing that is nice about Pandas is that it allows nice integration with other types of data science tools. And one of them that is very useful for everyone is visualization. There's some reason where by visualizing the data and the experiment, you get a lot of insights. You can, in a way, instead of looking at a lot of text, visualization is a powerful tool to both understand your data, but also to show the things that you want to show about your data to others. But there are tools in Pandas that allow you to do that. So now, if we take this just one line, let's say that I'm interested in the data frame data, the cell size column, and I want to create a histogram of that column. And notice that in just one line like this, I was able to create a histogram that's based on the data sizes or the cell sizes. I'm seeing what is the frequency of each one of those sizes. For example, if you're interested in getting the histogram of your data on cell sizes, all what you need to do in Pandas is just upload your CSV file, import it to Pandas, and call this function. 3 lines, and you can generate this. So in terms of exploring your data, this is the powerful mechanisms that you can get. Other examples, you can also create things like box plots, right? In this case, for cell size and cell types. I'm going to go quickly through these options, but just in a way to give you an idea of the things that we have here. You can also create scatter plots. For example, this is the scatter plot of the X and Y positions of the cells. So in a way, by just looking at this data frame here, we know that cells are actually covering the whole space that we have here for X and Y positions. Imagine that if for any reason that cells are maybe are more likely to be within a certain region, by creating this scatter plot, you can observe that by seeing that there are more points toward the regions where they tend to be. Some other things, we can have a pivot table, which is allows you to have summarize the data based on different aspects. So, for example, in this case, it's going to summarize data based on the average cell size and the cell type and the apparatus used. So you can get this table of features about the cell sizes based on the type of cell as well as the type of apparatus that you use. So this type of 2-dimensional analysis is also can be done as this single one. And here is some other integration that is also used widely, which is another library that is very useful called Matplotlib, which is a plotting library that is going to allow you to generate some nicer looking figures. In this case, you can also use this to generate figures. And you have more options in this case so that you can have more ways to customize your figures. But I think kind of like one thing that I want to show is this nice thing about Colab, which is imagine that if you now print data, if you go kind of like back to the bottom of it, you have new recommended plots. And if you turn this in, without you doing anything, you just loaded your data, uploaded your data, and just printed it out. And then you said that you want to see what are the recommended plots that you would figure out from my data. And then you have all these different examples that it tries to, in a way, show based on the data that you have. And if you press on any one of them, it's going to generate the code that you need to have to generate that plot for you. All right, so this is a quick overview about what we have in terms of Pandas and how we can use it for both cleaning, exploration, querying, as well as connecting it to do visualizations for us. A lot of what we did here, you can do in 3 to 4 lines of code. You can do them in just 3 to 4 lines of code. And I encourage you all to try it out with the data sets that we're going to provide in the course website and see it for yourself. So now we're going to stop a little bit and see if we have any questions either from audience or from Zoom. So let's start by reading the questions.
I don't really understand the question. How many data manipulation points we have to take?
So I think maybe that's relevant to one of the parts. How long ago was the question?
It was very recent.
Oh, very recent. So the number of let's say columns or features that you would include would be dependent on the type of plot that you're trying to do. So for example, in a histogram, it would be only one column that you're going to be using. If it's something more complex like a scatter plot, then you will be using 2 columns because each axis is going to be a different feature. If you have something like an index table, the last option that we had, you would have 3 features. That is trying to create something like a heat map based on 2 features and a 3rd feature that you are displaying. So it really depends on the type of figure that you're trying to generate. Of course, there is even like more complex ways of generating figures, like if you think about like 3-dimensional heat maps and things that are like super crazy in that sense. But yeah, at the end of the day, it depends on the type of figure. Yeah, there's another question.
Is the code, so Colab accessing both files at the same time, just like VS Code?
So in Colab, you can define an arbitrary number of files that you can use in your analysis. You can have different data frames, each for different data objects.
Should data be always normal?
So it depends on what is meant by normal.
A normal distribution.
Normal distribution, no, so it could be anything, right? So here data could be completely random and arbitrary, which is mostly the case in a lot of these videos. Maybe before we take one more Zoom question, any questions from the live audience here?
Yeah, so we can use Excel functions for a lot of these things. Is Python recommended or can we use any?
Yes, very good question. So actually, of course, spreadsheets is also a way that you can use or can do a lot of these functionalities. The main issue that you're trying to overcome with spreadsheets is that you hit a limit with spreadsheets where doing these things are either impractical or even sometimes impossible. Unfortunately, spreadsheets are, of course, well, maybe fortunately or unfortunately, spreadsheets are geared more towards ease of use more than practicality for larger data science problems. One way to think about it is that if your data size is small, spreadsheets would be the best solution to have because it's more usable, more accessible. If it starts getting into the order of gigabytes, then, or let's say hundreds of megabytes to gigabytes, then a Python and data wrangling would be your option. And if it gets even much bigger, then using a database would be your option then. And of course, there's a trade-off there between accessibility and flexibility there.
Yeah, usually biological data takes a lot of data sets, especially if you're talking about genomics data. So this is why it is really helpful to use Panda in your pipeline.
So this is Professor Koja, who's the co-instructor from UCSD. She mentioned that a lot of bioengineering experiments are huge data sets rather than smaller data sets. So maybe since we have a few minutes left, maybe I'm gonna kind of like just wrap up with some announcements for next week's, and then we can take a question, because I think for any of you who have something that they need to do, we're gonna stick around for like 10 more minutes to answer any questions beyond that. But before you leave, and before anyone leaves, I want to emphasize that next week is going to be really fun. I hope that like for anyone who is going to be able to come here, especially kind of like for those of you in CS. What we covered this week and last week might be kind of like very familiar to a lot of you. But next week is going to be where everyone is going to have fun, actually, including me. Like, I'm very interested for next week because there's going to be a lecture that is mainly driven by Professor Chen Li, who you've all met last week when we introduced the instructors. And what we're going to be doing is that he's going to give us a tutorial of using data flow tools, right? So think about this life cycle of data science. What Professor Lee has built in his lab and has worked on with his graduate students now for 5 to 6 years is building an interactive tool without having to code, without having kind of like to install any libraries or do anything. We can think of it as just kind of like adding blocks to a graphical interface, a block to read data, a block to filter data, a block to do some certain type of analysis and filtering. And all of this at a high level where you just connect blocks together to do the type of analysis that you're interested in doing. It's something that I started using and it's very fun. It's used in a lot of very interesting research projects around campus here and beyond campus in different universities and partners. So I don't want you to miss that opportunity. It's going to be fun. And I think he was still kind of like, I'm not sure if this is going to completely happen or not. But I think what he's planning to do is that he's going to have everyone have the opportunity to also participate and use that tool as he's showing it in the presentation. So if you can also bring your laptops, you might be able to use it yourselves and see how powerful it can be. All right, so with this, thank you for coming this week. I'm going to stick around and we'll see you next week if we don't see you again. All right. All right, so let's take more questions now.
Yeah, so there are just more questions about why use Python instead of several other different services. For example, Power BI, I've never heard about that. Have Tableau Cloud Service and Matplotlib, these kind of like other tools.
Very good, yeah. So this is a very good question. And I think this is part of what is exciting about data science now. We have a lot of different options to have. But maybe one thing that I would like to in a way differentiate is that a lot of these libraries and tools, whether it's Tableau, Power BI, and Matplotlib, visualization, facilitate analysis, and all these other parts, but a lot of the times you need a programming language to interact with them. But usually kind of like you would need a programming language to interact with them, and usually Python is the programming language of choice to do these interactions. So we gave an example for instance for Matplotlib, which is at the end of the lecture today. And Matplotlib, you can, of course, use it with different formats and different programming languages, but calling it within a Python program allows you to use Matplotlib as well as other libraries to do different things. But of course, that doesn't discount that there are other tools that everyone might kind of like have different preferences on what is the right level of the trade-off between complexity and accessibility that you would want to have in between. And sometimes these tools could be also for pay, right? Which, like sometimes it's nicer to have something that you can use for free.